Welcome to part 3 of Competency 10. In this video, we will work with the distance formula and the Pythagorean theorem. Number 1, given the points -2, 5, and 4, -7, what is the distance between the points? Okay, this is obviously a distance equation, situation, and I've given the distance formula for you. Okay, so what do we need to do? We're just going to put it in our calculator and solve in exactly the way that we would write it down to solve it. Okay, so second radical parentheses. Okay, so we want x2 minus x1. Okay, so that is 4, and you're going to subtract. Now you need your parentheses, and then put in your -2. Close your parentheses, another parentheses, and square it. Now, why did I do that? Well, that's an order of operations thing. Okay, try it other ways, and you'll see that again. Be careful. Type it in exactly because of order of operations. Okay. So add, open your parentheses again. Now we need to begin with the -7. Okay, -7 and subtract the 5. Okay, so -5, parentheses, closed, and square. Okay, and you can use your arrow to double check that you did it correctly. Always be careful that you understand and type in the negatives and subtraction correctly. And yeah, they in a lot of cases are the same thing, but the calculator doesn't know that. Okay. It's just one of those things you got to pick up quickly. Okay. So let's push enter. And there we go. That is our first option. Now, before we move on, I need to mention that the distance formula is not provided for you on with the formulas on that formula sheet on the computer. So, even and also if you take it at the university where it's paper based still, remember they're not paper based anymore. When you take it, it won't be on that either. They're only going to provide you with what the state of Texas would. Okay, so you need to commit it to memory, right? And by this point, we should have it committed anyway. So let's move on. Given the distance between the points -1x and 2, 6 is 5, what is the value of x? Well, this is an opportunity for us to use our table function, okay? Because we're just looking for this one variable, okay? So let's push table. Now, we need to clear out what's in here, okay? And say second radical, open your parentheses. So we need 6 minus 1. Okay, so 6, subtract in parentheses -1, close it. Remember, you got to type twice. Push your square. Now we add, open parentheses, and we need, uh-oh, I did the wrong thing. We need the x, and I put the, see what I did wrong? So I put 6 instead of the 2. It's not a big deal. Just type over. So here, let me show you what I did. And you probably saw it right away and you thought, what is she doing? And you're right, I was wrong. So you need the x2 minus the x1. Okay. So now we're dealing with the 6 and the x. Okay. So I arrow back over, go back to where I need to be, and I hadn't typed anything in because I realized what I had done. So 6, subtract the x, close your parentheses, and square it. Now enter. Now we have a setup exactly the way we need it because we're going to try each of these options, 6, 4, 2, and 3. Okay, so I just push enter. Okay, you need to delete out what's in here because that's from a prior question. Okay, so let's try 6. 6, enter. Oop, that's 3. Nah, I'd say that's not it. And you're like, well, wait a minute. What are we looking for? You said it's not 3. Ah, this is what we're looking for. It says it's equal to 5. So what is equal to 5? That would be our y value. And y was 3 there. Okay, if you've, and I mention this, if you've watched other videos, then you know what I'm doing. But if you haven't watched other videos, then you don't know. Okay. Well, videos where I've done this anyway. So 4 enter. Nah, I'm going to say no to that. How about 2? 2 enter. Ooh, that's a winner. C, option C, I would say 2 is it. But let's go back up and type over the 6 with the 3. 3, enter. No, that's incorrect. Okay. Yeah, it's unfortunate we only have 3 lines to work with in our view, but if you think about it, it's okay because at least they give us something like this. In the past, years ago, you wouldn't have had this nice calculator because the ones that they gave you were just simple for function. Now they said we could use scientific, and that's fabulous. Okay. All right, let's look at number 3. Given the points -2, 5 and 4, 7. That looks familiar. Okay. But they're asking something different here. And a third point in quadrant 3 of the coordinate plane. What are the coordinates of the third point that will form a right triangle? Ooh, that's a good one. I like this question. So if I draw my coordinate plane, okay, now we don't have to be perfect. Just sketch it in there, okay? So let's see what we got here. I say -2 is over here, and I'm going to say 5 is over here. So I'm going to put that dot here. So that's that one, okay? And then I'm going to say 4 is a little bit more over here, okay? But then it's going to be down a -7. So I have to go even further. Okay. So what am I making here? I'm going to make a right triangle. So I'm going to go down like this, and I have to go straight down here and then across here. And this has to be the point making the right triangle in the third quadrant. So I'm in Q3 here. It could have been in Q1, but that's not what the problem said. It said a third point. It says right here, Q quadrant 3. Okay. So we're in the right place. We're doing good. Now, what is that point going to be? Okay. Remember, the y value here, this was -7. And here, my x value was -2. So obviously, this point is -2, -7. And there we go. That would be option A. Now, think about it. We could have chosen B, right? Because -7 and -2 is still in Q3. Ooh, and I labeled that wrong. Hang on. I put 2 and this is 3. Sorry about that. Okay, so we're in the right quadrant. B would have been in the right quadrant, but if you think about it, when we started sketching this, it would have been more out here, and that would not have made a right triangle. It could have made a triangle, but it would not have been a proper right triangle. Okay, not, yeah, even if you try, it wouldn't be right. It, I'm looking at it and you're thinking, oh, it might be. No, I don't think so. I do believe if you look at it and think about it properly, it has to be A. All right, so let's get rid of that. Now, obviously, C and D, they're in the first quadrant and the numbers are off. So there's no way that C and D could be it. Okay, let's go to number 4. Number 4, find the value of C in terms of X using figure 1. Okay, so we see that figures 1 and 2 are special right triangles. And it is in your best interest to know how to work with these. Okay. It's common on the test for you. You will see it in eighth grade when you teach eighth grade. And also, it's very common in high school. Okay. And if you know the ins and outs of your special right triangles, you're going to find some questions a lot easier. Okay. All right. So let's take a look. What do we see? Well, we know that c squared equals what? Well, we know c, or taking it from c squared, we want c. So under the radical, we're going to have a squared plus b squared. Well, that's x squared plus x squared. Imagine that. So what does that really give us? We can add those x squares together. So we have 2x squared. Well, isn't there something that we can pull out of the radical? Yes, there is. We can pull x out of the radical, but 2 stays under the radical. Now, that is what c equals, okay? Oh, sorry. I was going to write it the wrong way. Okay, c equals what? C equals x square roots of 2. Okay. Now, if you know about right triangles, you know exactly where these questions are headed. Okay. Take a quick look at figure 1. It looks like to me that x is like you're multiplying x to the square root of 2. Well, what about x times something else? Okay. And if you look at figure 2, you may already see it. Okay. Or you've already worked with special right triangles and this is Captain Obvious, Kind of feel like I'm stating the obvious here. But let's look at the next question. Find the value of y. Oh, let me scoot back down. Sorry, guys. You want to see the diagram, right? Okay, it'll be the second one with y. Find the value of y in figure 2. Okay. Well, what do we really need to do here? We'll look at figure 1. I'm going to say x equals 1. They're the same triangle, ladies and gentlemen. They're just trying to get you to understand that x equals 1, right? So now, what would y equal? So if I want to find y is c. Well, if x is 1, then y must equal the square root of 2. Okay? Let's use our calculator and double check that. A lot of you are saying, yes, it is. I know it is because I've done this before. Anyway, let's give it a go. So we need second radical. Well, 1 squared plus 1 squared equals what, guys? 2 squared. So that's what I was looking at the diagram, and I was trying to point out that if you look at figure 2, this would be the case. Y equals the square root of 2 because the legs are equal to 1. If the legs are anything else other than 1, then they have to be multiplied to the square root of 2 to get your hypotenuse. Okay? It's just something that you need to recognize when you have the special isosceles right triangle. Okay? Notice it's isosceles because you turn, if you turn it to where you recognize it, you have the right triangle, but then the other two angles are congruent and the legs are congruent. Okay. All right. So let's move on to number 6. Number 6, find the value of x in figure 3. Okay, figure 3 is what I like to call a 1, 2, 3 triangle. It is a special right triangle. Notice the degrees are 30, 60, 90. And 30, 60, 90 is usually how it's referred to in the classroom and textbooks. But I call it a 1, 2, 3, and you'll see why. So second radical, and to find x, we need 2 squared minus 1 squared. Okay, I've entered it correctly. And that is the square root of 3. That's where I get the 1, 2, 3 from. But you have to remember, it is not an integer of 3. And of course, these are wrong. Okay. That's why I call it a 1, 2, 3. So I remember the value of leg B. Okay. Remember, this is A. Then this will be C. So x is actually our b, which is equal to the square root of 3. Now, let's look at the other triangle. Well, isn't it the same triangle? Yes, it is the same triangle. However, be observant. Well, I think 2 is multiplied to x for the hypotenuse, and I think leg A is multiplied to the 1 because A equaled 1 in figure 3. So I'm thinking that figure 4 is multiplied by x. Well, if one of the sides, meaning a leg or the hypotenuse, is multiplied by x, some value x, well, all three have to be, or it's no longer a right triangle. So to keep that label or continuity, we must be we must multiply all the legs by the same thing, or our angles go wacky, right? So that means we would have x square roots of 3. Everything will be multiplied by x. So now let's look at number 7. And it says find the value of b in figure 4. Well, we've already found it. And you probably saw that right away. If you've worked with these triangles at all, you would have automatically said, oh, I know what that is because I worked with it and there's nothing else it can be. Now, word of warning, you try to put this in the calculator in some way using the table, setting up the formula, or putting it in straight. It's not going to work. You're just going to keep getting 0 everywhere because of the way the values of x would be used, okay? So that's just one of the properties that we have to learn and know when we're taking the test and we're teaching. All right. I want to thank everybody for watching the videos and again making it all the way to the end of one of these videos. And I'm sure, well, I know a lot of you are watching several of them, and I've noticed I have over 200 right now. So kudos to you. You're really sticking to it. I really wish you the best. And thank you for liking and sharing and subscribing. Okay. Happy testing, everyone.